So we'll just try to solve the 2024 paper. In this paper, we have four questions. The first question, just go through the question. This task, there is a particular task, and they are starting it on June 1st. And June 1st, and this is just some context. They're saying this is a recording studio, and we're constructing the recording studio. And these are the jobs or the activities which are involved, and these are the predecessors for the particular activities. Instead of a direct time, they are given three different time estimates. One is optimistic, one is pessimistic, P pessimistic, O is optimistic, and M is most likely. So they are not given direct time, means you are not given a direct estimate. This is the perfect estimate. In this case, how should we get the time for the entire scenario? And the question is determine the expected completion time, which is the critical path, which is the critical path's time basically, and also the critical path means which are the nodes. Also determine the expected earliest and latest start and finish time for each of the separate activities. 7-day working and there is no holiday. Okay, this is nothing but AON model. So for those who have seen the videos earlier, this is AON model. And for AON model, when we are seeing the PERT, let us jump directly into Excel. So I already have given all the values over here. For now, I'll remove this so you can understand it. At any point, if you want to speak anything or if you have doubts, just let
रघुनाथ
me
एक
know.
बारी रघुनाथ एक बारी जो पास्ट पेपर है वो भी ग्रुप पे प्लीज शेयर कर दो.
Okay, I'll send the paper. I think paper is already there. हाँ. So just the data, I have just copied it from here. See the job activities, A to K, there are the activities, and they have given the predecessor nodes, and they have given all the values A, M, B, and then we are calculating. Okay, let me also calculate this. So this is just the value, nothing else. So only the values from there I have just copied and put them here. Now we have to calculate the time for the job activity. So for this, the formula is this value, this you can consider ABM. Okay, let me also not take like that. So this they gave as optimistic, most likely, and P, right? So I'm also taking the same optimistic, most likely, and P. So now how do you get the time for each job, which is nothing but O plus 4M, 4 into M plus P divided by 6. The O value, whatever is the optimistic value, plus 4 times most likely plus pessimistic value divided by 6, because the numerator, the value 6 values have been taken because you're multiplying 4 times. That's why you're dividing by 6. Don't want to get into the logic, just remember this formula. This optimistic plus 4M into P by 6. So that you can give it in the Excel directly. O plus 4 times M plus P. This value by 6. Then you just simply drag it. So once that is over, next we have to find the standard deviation sigma. The formula for that is this value O minus P, this divided by 6 whole to the power 2, which is nothing but A minus B by 6 the whole square. That is basically the sigma value. So once you get the value, just put it, and similarly in the Excel also you can calculate it. Here we are also taking then similarly. This is the optimistic value minus P divided by 6, entire thing. So here power of this value comma 2. So okay, let me do it again starting. Is equal to power of, so this is the number, just put comma and 2. Now in the numbers place we have tried the formula. Formula is O minus P divided by 6. This is how you have tried the formula. Then simply drag it. Fine, this is good. Now, after this, once you have done these things in Excel, you have to manually draw the network diagram for this values A, B, C, D, like I have shown in the network path. So how can you draw it is manually how you draw is, let me just show that also here itself. So once you set up this thing, here will be your node value. Then this is your early start and early finish and late start and late finish. So this is nothing but this value plus this. And this is equal to this minus. So this is how you make a node. Now this node, just copy it. Now you have made one node. You need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 nodes. Just copy and paste them whenever you need. So this is, I think you understood how to make a node. Just you have to draw it in a paper. So just don't worry about how to make it in Excel if you're not understanding that. So here, see the precedence. A has no precedence. So A should be the starting one. How do you make a starting one is just put here a start, and then just draw an arrow mark from here to A. I'll just show that later. I'll show you one image, just look at there. See, suppose this is the crashing which has been given. So this is the diagram of the network which has been given. So you just write one start, draw a circle. From there you mark the arrow and then you finish the network diagram like this. So how to do it and all, I have shown it here. So first thing is start. After start you have A. Next node is B. B also there is no predecessor. Then just pick it up, write it below this and put B. Following A, B, then C. C also there is no predecessor. Again, you just draw it and put it here, and this is C. Next for D, they say C is the predecessor. So C is the predecessor for D. Now this becomes D. Then for E, A is the predecessor. Means E follows A. From A, here we get E.
Here, here, it's calling. He's asking for a
It
recording.
is recording.
It is getting recorded.
So then the next node is F. F is having B, D, and E as predecessors. So B, D, and E all are having with F. All are having F. Then for G, G the predecessor is F. This is F. So when you are writing, just put the arrow marks over here, right? Okay, let me just put them also. See, so from the starting, just a minute. Yeah. So from start to A, so this is how you draw it. Then from start to B again, because A, B, and C are having no predecessors. So once you are done this, then they said A, B, C are done. So D comes after C. So D comes after C. Then just put one more arrow, D to C. Then E follows A. So from E to A, then F is following B, D, and E. F is following B, D, and E. So this, and this you can do it manually on the paper. B, D, and E. Then G is followed by F. So we don't have any node. So like just copy this node and paste it. Now this is G. This value is G. And they said G is followed by F. So just comes here. And again H. H comes over here. Just put H. And then put the arrow marks. I'll put it once I draw everything. G, H, then I, J, and K. I is following G and H. So I is following G and H. I. Then J is following H. This value is J. Then K is following I and J. I hope you are clear with the drawing this diagram. Just you have to put the arrows here, which we will do it now. Right, we have done until F. Post F, G. G is followed by G's predecessor is F. So G's predecessor is F. That is done. Then H predecessor for H is also F. Predecessor for H is also F. Then predecessor for I are G and H. I are G and H, like this. Then for J is only H. For J it's only H. Then for K, the predecessor I and J. So this is I and J. Then once you're done with the last node, then this will just have one more end here and you can just say it as finish. So this is how you draw the diagram. From the start, get every node. After every node, just put the values and then put the connecting arrows on paper and then finish it. This is how you have to finish the node also. Then we have to enter the values. So what are the cost values? These are the cost values. We have calculated, right? All the TI. What all we have calculated over here. This is the cost value we'll be putting. So for A, the cost is 3, right? Then for B, the cost is 5. For C, cost is 6. For D, the cost is 8. Then for E, it is 6. F, it is 32. And G, it is 22. H, it is 22. H is 11. H is 11. Then I is 16. Then J is 20. And K is 5. So once put the cost, then how do we start? We start from the first nodes. All these 3 nodes start simultaneously. So the starting times are 0 only. Again 0. So early start, this is early start. ES early start and this is early finish. So early start for the first nodes is 0. Early finish is 0 plus 3. So 0, ignore this -3 for the time being. 0 plus 3 gives your early finish. Similarly for B, 0 plus 5, 0 plus 6. Now for the next node, this E is only having one predecessor. So whatever is the early finish means after finishing A, you will start E. So start time for E is 3. Then what is the finish time? 9. Then for D, see for D was also having only one predecessor. So it will take again 6. Then it took 14. For F, there are 3 predecessors, not one, not 2, 3 predecessors are there. E, B, and also D. Then what will be the start time? The maximum of these 3 will be the start time. So then how can you do it? Is equal to max of this value, comma this value, comma this value. You can also do it manually. I'm just doing it so Excel is automated. So this part is done. After this, 14 plus 32, 46. Yeah, someone is speaking. No one? Okay. So the next successive nodes, they again take 46, which when F is finished, 46, then G and H will start. Same 46 over here and 46 over here. Then you get automatically the early finish. Next, if you see for I is having 2 predecessors. So whatever is the maximum, when you're moving forward, you take the maximum. When you're moving backward, you take the minimum. Forward means the upper nodes. So once you got the maximum value. But for J, there is only one predecessor. So it will only take the value of 57. Once these both are done, now K. K will take the maximum of both the predecessors. These two. Now this is done. Now we have come to finish. Now the forward has been calculated and the cost, critical path cost is 89, which means the project can be completed in 89 days. Now, when you're moving backward, the immediately the predecessor node after finish means the next node to finish is having the same time. This is late finish and this is late start. So late finish means what? This is the same value because it is a finishing node. Whatever value, whenever date it is being finished, it will be the same. In the free float method, we have already seen how to calculate the values for early start, early finish, late start, and late finish. Now for these two nodes, this is the only successive node. After K is finished, we are going backwards now in the back direction, starting from K. So once K is finished, means after 84, these will be the early finishes time. So this is 84 and this is also 84. See, once you have entered 84, automatically the value has been calculated. Next for H, H will be the minimum of these two. Why? Because it has two successors, both 68 and 64. So it will be minimum of 68, comma 64. 64 is taken. For this, there is only one successor node. So it will only take the value 68. After 68, immediately you have got the early finish. So what is this value? This is nothing but late finish minus the node activity time. Right? So for this, it is nothing but again, because it is having two successors, minimum of 46, comma 53. When you're moving forward, you take the maximum. When you're moving backward, you take the minimum. Then for this node, there is only one successor, right? There are not many successors, only one successor. So it will directly take 14. Again, for B only F is a successor. So it will also take 14. For D also only F is a successor. So it's also taking 14. Then for C, D is a successor. D is finishing at 6. So this will take 6. For A, E is a successor. So this is finishing at 8. So this will also take 8. So you see, C has to start from 0 itself. 0, 0 means early start and late start. Early start means the earliest time when the job should be started. Late start means do we have any leeway? Now, if you see B, early start is 0 means you can start in 0 and finish in 5, or you can start at time t is equal to 9 or 9 days at t is equal to 9 days and finish at 14 days or weeks, whatever is the unit. So then we have some slack of 9 units. This is how we have got the entire node. This you can draw on paper. You need not do it on Excel. So once you have done this thing, now we have to find the critical path. The critical path is the one which is having the longest path. So here if you see what is the longest path starting from K, because 89 is here. So K. Next, even one more entity is in critical paths, the early start, early finish, late start, late finish are same. Means this early start and late start, early finish and late finish, both are same. Both are same on the critical paths node. But if they are same, doesn't mean that they should be same everywhere. How that?
यार मेरा एक डाउट है, जब तूने ये नोड बनाए थे
Hmm.
तो तूने कुछ मतलब कुछ ये जो 6 सेल्स थे उसमें कुछ प्लस माइनस किया था, वो क्या किया था वो समझ नहीं
Okay. So as first
Raghu,
select.
if you can write the formulas there, like if you can make a note,
Okay.
best.
So yeah, see, one I have made the node here first of all, then made it bold and increase its size. Next, here is nothing but the node name, whatever is the name A, B, C, D, and everything. This is the node's time, whatever is the time we have got from here, that comes in middle. Then here, this value, this value which is above it is called as early start, represented as ES. And this node is named as early finish, which is EF. Early start and early finish, suppose you think just as a node, consider this to be a construction activity. That is the name of this. This construction is taking 5 days. If it is a starting at t is equal to 0, when will it finish? 0 plus time, right? So that is the early start and early finish. Or suppose this to be some x, then what will be this time? This will be x plus time. This at this time at clock t at clock 10 o'clock, if this has been started and it suppose the exam is our exam is at 10 a.m. and it takes 2 hours for our duration, when will the exam finish? 10 plus 2, 12. At 12 o'clock our exam will finish. If it is, this is when we are moving forward. When you're moving backward, you will know this time. When you're moving forward, so you'll know the start time, right? You're moving in this direction, so you know the start time, then you are calculating the finish time. When you're moving backward, then you'll know the finish time. Say the finish time is Y. You know your exam finishes at 12 o'clock and you know the duration is 2 hours. Then what is the start time? Y minus time. This is called as late start and this is called as late finish. Okay, so this is clear, I guess.
Got it.
Yeah. So once you are done with that part, just draw the diagram on the paper. Then we get the critical path, which is leading us to the longest path or the maximum duration for the project to start and finish. So now I think you can see the entire project. So here, if you see, when we start, you can go it any way. You can go manually also. You can go A, E, F, G, I. You can see if it is leading to a critical path. Now, if you start from C, then D, then F, then G, then I, and then K. Now see, is it a critical path? Critical path, the nodes have same early start and early finish. Late start and late finish is also the same. Not necessary that if a node is having that value, it is a part of critical path, but it is the other way around. If it is same, then there is a chance it will be a part of critical path. It is not necessary, right? So we have started with C, then from C we have moved to D. If you see for D, it is the same 6 and 14. Then you have moved to F. Again here they are same. So F. Next you have moved to G. You did not come to H because these are different. So this is definitely not critical path. If these are different, you are sure that it is not a part of the critical path. If these are same, there is a chance that it could become a critical path. Then you move forward for I. Yeah, it is same for I. Then it is for K. This is how you got your critical path C, D, G, I, and K. So until here, is it clear? How do you get the critical path?
Raghunath, one doubt. If
Yeah.
let's say G and H both have same early start and late start,
Which
let's say
is having
46,
C
46,
and
46, 46.
C and
G and H.
G and H. Huh, okay.
Same, like 46 as early start as well as the late start for both of them.
Okay.
Okay.
Hmm.
Is there any chance it could happen? And if then what should we select? for
There
that?
could be more than one critical path. Not necessary that there is only one critical path.
अच्छा, so it doesn't
There,
depend कि time किसका ज़्यादा है. 20 to 11 में it might happen ना that we choose with the one who has the more time.
no, critical
ऐसा
path you
कुछ
could have more than one. Not necessary that you should only have one critical path. There can be more than one critical paths.
ठीक है, ठीक है, ठीक
So when you have more than one critical path, what we do is we write more than one, all the paths which are possible and say these are all the critical paths.
है. Got it. ठीक है.
Yeah. So once you have got your critical paths, just highlight the nodes so that we need to go further in the calculations. That's why just highlight the nodes C, D, F, G, I, and K. Like here, just highlight the nodes. Now this part is clear, the construction, how to get the time, early start, early finish, how to get the critical path. This is how we do the critical path using the free float method. Then see the question, determine the expected completion time. So what is the expected completion time? 89. Because that is the longest path and that is the maximum duration this project can take to finish. Next question is, and the critical path for the project. So the critical path for the project is C, D, F, G, I, and K. We have already done it. Then also determine the expected earliest and latest start and finish time for each of the separate activities. So it is already there. Earliest start, earliest finish, latest start, and latest finish that we have already calculated. So A part is done, right? For A part, I think everyone is clear. Next, for the B part, they're saying the company has committed themselves for 99 days from now. Means they're expecting within 99 days from the start to finish the project. What is the probability that they will be able to begin recording? Means they are asking simply the probability that the project is 100% complete in 99 days, or they want the probability or the chances that within 99 days your project is finished. Now you might get a doubt. We said that the critical path is 89. 89 is the maximum duration. So how come they are giving 99 days and still asking probability? The issue is these are optimistic, most likely, and pessimistic values. This is not definite. These values are just estimates. There can be many hurdles in between and many issues might come up. This is just an estimate, right? So in order to know the entire probability of actual occurrence, that is why we are doing the PERT analysis. Here, how do you get the value? Now for this, there is a formula which is called norm.dist, the first one. Now for this, okay, let me before that, our x is 99 days. Now take it. Now norm.dist. Now they are saying probability that the project finishes in 99 days. This is 99 because that is the x value, mean. So what is the mean? Mean is nothing but these values, but only those nodes which are in the critical path because they are the ones which are taking longest time. So that sum we have to calculate. Standard deviation is nothing but sigma. Here it is sigma square. This value what we calculate is sigma square. We need to sum those nodes of the critical value and do the square root and get it. So let us do that. Observe how we are doing it. The mean is nothing but sum of only these values, only those of critical nodes, wherever the node is, and that's why I said to highlight it. So it is easy to understand, easy to find them while you are getting the sum. So only this is the mean. We are doing mean of these because they are part of critical node, critical path. Why critical path? Because it is the longest time taken. Then this is sigma square actually. So sigma square. Now we need to get sigma. First do the sigma square. Again you get the sum. Again the sum of only the critical nodes. This one, then this one, then this one, and this, and this. Now you get the sigma. Sigma value, how do you get? Just do the square root, SQRT. Square root function. Select the cell. Now the probability that the project finishes in 99 days. It is nothing but norm.dist. X value is the number of days, 99. The mean is the mean value. Standard deviation, which is nothing but sigma value. Cumulative is true. So put 1 and close it. So there is a 92% chance that this project will be finished in 99 days. So can you reverse check it? Means 92%. Now they are saying reverse it. They did not ask in the question actually, but in class ma'am has said, so I'm just saying it. If there is a 92% probability, then how many days will the project be finished? There is an inverse. If you are given days, how to find the probability? If you are given the probability, how to find the days? So for that, just use norm inverse. See, the norm inverse is just below norm.dist. Norm inverse probability is 92. So 0.92. The mean is the same mean, and standard deviation is sigma. See 98.8, which is nothing but 99 days. So this is the second part's answer. So I think PERT
रघु, जो नॉर्म डिस्ट में लास्ट में क्यूमुलेटिव में तूने 1 डाला था तो वो हमेशा 1 ही रहेगा.
हाँ, for every it will be 1.
ठीक है.
For PERT it will be 1. Okay. So I think this is clear. So this is for the A1 part. So I think meeting will be finished in 8 minutes. So I'll just send you another link. Do you want me to continue this? You want the solution for all, or just want the file? Guys who are on the call, you want the file or you want मतलब you want me to explain completely or
you
just
can
file?
send the file.
Okay.
You can send the file afterwards, like if you have done everything, I guess. Then उसके बाद तो भेज ही देना.
Yeah,
हाँ,
no,
मतलब अभी
I'm
तो
saying,
एक्सप्लेन कर रहे हो, टाइम है तो कर दो.
अच्छा, you want explanation also? Okay. Okay, so first question is done, guys. This first part of the question is been done. 1A, 1AB is done. The OR question is the crashing. Crashing, I will not be able to explain. Achha, okay, I'll just simply make you go through crashing. This is a template I have created for crashing. So as previously drawn, just make this node. After you make this node, you have to make, Achha, this is somewhat complicated. Okay, crashing, you do one thing, I'll send a video link, just watch that video. That is more simple to understand. Crashing explanation is quite difficult, but for doing it is easy. Those who already know the basic concept of crashing can just go through this Excel sheet. I'll share it in the group. That will be better. And
यार एक बार brief में समझा देना ना crashing. Like if you can, like 5 or 10
but
minutes.
anyway, you'll be getting it in choice, no?
Sure है ना?
B, they are saying B section, ma'am said it will be in choice.
Okay. ठीक है.
So that's
That's
why I'm
fine.
just leaving it. So let's see the second question. In the second question, they have said, just skipping on the other part there because time is less. They're saying units arrive. See the cursor, follow the cursor. The second question says units are arriving, means the arrival rate, which is lambda. They are giving it 100 per hour. And they are saying each operator can operate at 60 units per hour. This is service rate. So in the MMK template, lambda is 100 units per hour. This is lambda, which is the arrival rate. See arrival rate. Then mu, it is service 60 units per hour. Then they are also said that there are two persons who are operating, two drills. Two drills means servers are two. There are two servers. S is equal to 2. Now, just simply see the question. I'll just read it. The manufacturing company has an assembly line. There are two drilling presses, which means there are two servers. As partially completed products means products come onto it, and their arrival rate is 100 per hour and service rate is 60 per hour. Compute all the operations characteristics. You need not do anything. You just have to enter these three. You will get all operation characteristics here itself. Whatever is shown in results, that is what you have to write. As you already studied in OM, L is nothing but the length of the queue. LQ is length of the system. LQ is nothing but the length of the queue. W is the waiting time in the entire system. WQ is the waiting time in the queue. Rho is the efficiency or utilization. Same terms, just you have to write them. Just write L and then length of the system, LQ length of the queue. Just write in words. Don't just write L and leave. Write the other things also, rate of system and all. Then that first part is done of this question. Second part, further the company has found if more than 3 units on an average are waiting to be processed at any working station, then too much money is being tied up. The company estimates that each unit waiting costs 50 per day. Alternatively, they are hiring a third machine, it will cost 150. So they're basically saying the number of units which are waiting to be serviced, if it is more than 3, then it is taking a cost of 50 per day for each unit. Each unit waiting will cost 50 per day. Otherwise, they want to reduce the waiting. How can you reduce waiting? They are trying to bring a third server or third press, which will cost 150. Now you have to do the cost analysis. Should we bring the new machine or should we keep the waiting? So how many are waiting? If you see here, the length of the queue 3.7. 3.7 is the number who are waiting. If they say more than 3 are waiting, more than 3 means how many units are waiting? 0.78 units. So 0.78 into cost per waiting of each unit is 50. So the total cost is around 40, but a new presser will cost you 150. So it is better to wait, right, than to install a new machine and cost 150. So they should not install the third machine and they just wait, keep them in waiting because relative cost is high for third machine. And if also see, if you keep the third machine, the efficiency, the utilization has gone down 55%. I'll just do it again. If I have 2 servers, the efficiency or utilization is 83%. But if I have 3 machines, the utilization is 55%, which means utilization is efficiency of the machine system use, which has gone down. So these are the 2 reasons why we will not install the third machine. Right? This question is clear?
I have a doubt.
Ah.
Here the number 39 is for 1 hour, na? So it is telling about a day. So what should we do
So if
then?
per day, this lambda is also per 1 hour, 100 per hour. Right? See, arrival is 100 per hour, 60 per hour. In the similar way, 100 per hour means say 24 hours. What will you do lambda? 100 into 24, na? Let us put it
Yes,
2400. ठीक है?
Hmm.
100 is arrival per hour. One day, 24 hours. So in day, 2400 units are arriving per day. Into
Hmm.
24. Mu also into 24. No.
Hmm.
60 into 24. 16 24 means how much? 4, 6, 24, 12, 144. 144.0. Right?
Okay, got
Even
it.
then you are getting the LQ the same, rho same. Why?
Hmm.
Lambda by mu. They cross out.
Got it.
Lambda divided by mu, right? So if you're multiplying both numerator and denominator by 24, it will be the same. Okay?
Got it. Hmm.
Right? Yeah. Anyone else? Okay. For this one, we'll stop until here. I'll send one.